So I will explain and show this project we have been developing in Brazil, which is a collaborative work to map the land use and land cover on the country. So this project started by this with this inspiration. Brazil is the fifth largest emitter of greenhouse gas, and 70% of the emissions come from the land use sector. So contrary to the other, four main emitters, which are China, US, Russia, and India, which has most of the emissions related to burning of fossil fuels. In our case, it's related to the land use. So for many years, Brazil has been pioneering on monitoring the deforestation, which is a process, not even the land use change itself, but it's just a process. And we have been doing this since the late 80s with different systems, just monitoring this process of deforestation. But this is not enough to understand, if you want to understand the dynamics of the emissions and removals of greenhouse gas. So that was the inspiration originally, was, yeah, let's find a way in which we can understand all the changes that are happening, from what happens after deforestation, and then what type of land use that will come afterwards, if some of them is actually coming back to restoration, for example. And so what we want to do is to go from an understanding of land use changes, basically forest, non-forest, or tree cover gain, tree cover loss, to something more complex by understanding all the land use changes that are happening. So back then we create this network with NGOs, universities, and startups and technology to develop this systematic way to map and monitor the land cover, land use year by year in Brazil, and by doing so understand the transitions that are happening. So the approach that we use has this main characteristics. We start with the using the archive of Landsat since 85, and then we do all the processing pixel by pixel, and we combine the machine learning with the local expertise to by understanding exactly what we want to map, and mixing this with the the powerful tools that we have on machine learning, then, and using a lot of cloud-based processing. So then we are able to produce the maps for all the regions and all the years all together at the same time. So this is an evolution. So from collection to collection. So every year we have a new collection of data where we reprocess the whole period from 85 to the present year. So we are doing now 85 to 2020. We are increasing year by year. We're increasing also the level of details and number of classes that we are mapping. So this is the map that is currently published on collection 5, which has different types of forests, non-forest formations, different types of farming, crops like soybean, sugarcane, and others, non-vegetated areas, and water. And so this will be evolving over the time as we get to the new collections. The process in which we do the maps is a little bit different from the normal process of land use mapping. So instead of mapping all the classes at the same time, we create maps for each one of the class separate, making like the best map of each class. And then we have a process of filtering and integrate all those maps to actually produce the final map for each one of the years. And all the classification is done by all the years all together. So this at the end goes to a platform where you have one map for each year on the 30-meter resolution with those 21 classes with a global accuracy of 90%. And you can navigate on those maps on time and space. So for example, if I zoom in here in the Xingu area, in the border of the Amazon and Cerrados, I can see like what's the land use was in 85, just to locate yourselves, like what is yellow here is pasture, what's the dark green is dense forest, the light green would be like a more open forest, the brown thing here is like grasslands, natural grasslands, and the pink, for example, here would be cropland, mostly soybean. And so if you can go by year, but then if I go directly, for example, to 2019, then I would see a big transformation happening in this territory, mainly with forests turning into pasture and cropland, and some pasture turning into cropland and stuff like that. And so for any territory that you choose, you can see the change on the map, but you also can see the statistics of how the changes happening on each one of the classes. Yeah, and you can go all the way for the 30-meter resolution. Yeah, all the data you can download from here. The area for each one of the classes in different levels of details, and you can do this for different cuts on the territory. So, for example, here I'm looking to one municipality in the Amazon, one of the 5,500 municipalities in Brazil, and I can see the situation in 85. This is Sinop in Mato Grosso, and what we have now, basically everything turning into soybean, and yeah, and then you can have this tool where we can compare pairs of years to understand what is the change that is happening. And so you can choose any pair of years. Here, I'm just looking for the year one and last year, and you will see, yeah, what changed. So what is in gray didn't change. What is in red have changed. And then you can navigate over the change. For example, to choose just to see on the map. I want to see and understand in the map what was forest and now is cropland. In this case, soybean and cotton mostly. So you go back to the map, and now you're just seeing on the map only the areas that were forests and now are cropland. And then you can add layers. So, for example, you can see this information for every single property in Brazil, because all the layers of the properties are also there. And there are some other features to navigate. So it's really a way to understand the dynamics of the land use all over the country. This can be done by default in the platform for each one of the 6 biomes, the 27 states, all the municipalities, the watersheds, the indigenous areas, protected areas, and several other ways of kind of understanding what is the changes that are happening. So you can see some things as we do that. For example, using this data, we know that about 67% of Brazil is covered in natural forests. We're not saying that this is not degraded or it's just all primary, but it's just saying like this. We know that this is like the cover is like about 6-7%, and about 30% of the country is farming land. A lot of pasture also. Also, we could understand what is the loss. The net loss of natural vegetation in Brazil is about 87 million hectares in this period, which is equivalent to 2 times Germany, for example. And because we know what was the transition, so we can say that 90% of this loss was areas that were converted into crop or pasture land. And then you can have this also, detailed by urban area, mining, and et cetera, in the platform. The other interesting thing is to understand what are the types of land tenure in which the transitions are happening. So if I take again the native vegetation loss by land tenure, you will see that on private land concentrates 6-7% of all the losses of native vegetation that we had in Brazil in this period. If you take the protected areas, just 1.5, and if you take, for example, just the indigenous lands, it's less than 1%. So you clearly see where actually you have the responsibles for all this, loss of native vegetation. The other interesting things that we can, you can take, for example, from this data is to estimate how much of the present native vegetation that we have in Brazil, forest and non-forest, 9% at least is what we could call secondary vegetation. Means that between 85 and now, it has been clear-cut at least once, converted to some other land use, and then now it's back into going back to forest. And this is higher in certain biomes like Caatinga and Pampa, and lowers in others like Amazonia and Pantanal. But it's impressive that 5% of the vegetation that we have in the Amazon today is actually secondary vegetation, not by degradation, just secondary vegetation because it was clear cut and now it's regrowing. Not that this is like a very positive thing in a way it's happening, because there is a lot of this secondary, most of the secondary vegetation is just areas that has been abandoned. Yeah, and we can get other data also in relation to this. For example, how much of the area that has been clear cut in the Amazon that is actually really productive after that. So 63% of everything that has been clear cut in the Amazon since 85 turned into degraded pasture land. 23% was abandoned and is being regrowing, and about just 14% is actually being used by cropland, mining, urban areas, or something that is more productive. So in a nutshell, we are just basically cutting down forests with not a very good economic purpose, for example. So we also have in the platform some other features that are new products that allows for other types of analysis. One is we are mapping all the irrigation in Brazil. Again, starts in 2000 to 2020. Now it's gone back to 85. We are also mapping the quality of the pasture. As you know, like pasture land is the biggest use of land in Brazil. It's about 170 million hectares. And this is, so we are analyzing the quality of the pasture because a big chunk of those pasture lands is in degradation, so it's emitting carbon. And it's important to understand how much of this is actually turning into well-managed pasture, which will be sinking carbon. And this is a big difference for example, for the greenhouse gas balance. Also, there is a whole area, work that we are doing on fire scars. So it's mapping the fire scars over the time, monthly basis since 85. So we can understand how much of the country has been on fire, what type of land cover that has been on fire or land use, and what's the frequency of fire also. And same thing we are doing with water. So it's measuring the water surface monthly basis since 85. And those two products will be launching in July. And we have also this data on infrastructure, which is basically we plot all the infrastructure for energy and transportation in Brazil. And so you can choose any one of them. For example, this example here is federal roads, and you can make analysis on a buffer of 5, 10, or 20 kilometers to understand how land use change over the time along these infrastructures, both for energy and transportation. So there's an example here in the state of Rondônia. This is in the left side 85, and then in 2019, and you clearly see that there is an immense loss of forest. In this case, it's close to 60% loss of forest along the roads, and the average in the Amazon, the loss is 19%, and then here we're talking about like a loss of 3 times that in this region. Yeah, so this work has been done for since 2015 for the Amazon, and we have been starting to work with to expand this to other regions. So we have an initiative that we call MapBiomas Amazon, which incorporates not just the Amazon in Brazil, but also all the other 8 countries, which is in the second collection, producing data for all the Amazon basin. There is another one working with the Chaco region, between Bolivia, Paraguay, and Argentina. Another one that's working with the Uruguay and southern Brazil, southern Argentina, which we call Pampa. And there is also an initiative in Indonesia that will be launching the first collection of data in probably in 3 weeks. So these are the organizations. So in each region, we have different groups working. Always is a combination of local organizations collaborating with the collaboration between NGOs, startups, and universities, producing this the same type of mapping for each one of those regions, time series, and et cetera, to make available. So I'll stop here. So then we can have questions and we can discuss a little bit about that.
Okay, thank you, Tasso. I'll come back on, and if anyone has any questions, please put them in the question and answer section. I have a question for you, Tasso.
Yep.
Okay, on that slide where you showed the analysis done on the roads, I'm curious because you just showed the area that's inside of the Amazon and showed how much deforestation, degradation there was in that buffer along the road. What about if you did an analysis in the Atlantic forest area? Do you see the same thing, or do you see something different?
Yeah, so that's the point there is that you can, you can do this for any part of the country, right? For any state, any place. Yeah. So if you compare Rondônia to the, let's say, state of São Paulo, for example, which will be the one that you have a lot of roads, you will not see so much change in the case of São Paulo, because most of the deforestation that happens along the roads in São Paulo happens before the 80s. Right. Most of that it was in the 60s and 70s. So you will not see this effect. But you will see a similar effect that you have on Rondônia happen in Pará, Mato Grosso, virtually all the Amazon states. And also you will see this on this region that we call Mato Piba, which is a region that we have an immense growth of deforestation and growth of agricultural production for soybean mostly in the recent years. So in those places you will see this vast change along the roads, because the roads are kind of the means in which you get to the places to start to open. But you can see also the same thing happen on hydropower plants. So whenever you have an hydropower plant, you also have along, on the borders of this region, you have like deforestation. But in some regions, for example, if you take Paraná in the south of Brazil, where we have Foz do Iguaçu, and we have this big, I think the biggest power plant in the world or something like this, Itaipu, then there is a different effect, was that this area was totally clear-cut when they make they were making the plant, and there were the only piece of forest that you have there was protected as a park. And now the lake, around the lake, is actually being, there is a lot of reforestation. So it's actually, you see regrowth in this region. So yeah, so depending on where you are in the history, you see things different. But definitely what we learn is that if there is a forest and there is a road crossing the forest, the chance that you have a deforestation, it's very high if it's not protected.
Yeah, the reason I asked about the Atlantic forest is that I saw some recent work suggesting that there's actually forest regrowth going on in the Atlantic forest area, because a lot of people from there are moving out of the Atlantic forest area into Amazonia or into other places. And so I was just wondering if that type of analysis had been done there. What you said in the South is very interesting. I have seen a similar phenomenon in Thailand, where there's been a lot of road building, but near the roads, there's been an increase in forest plantations as people are leaving to go into the cities. Okay, there is a question that came in. And so according to the data, Cerrado is suffering more deforestation than other regions. Is that correct, and why?
Yeah, I would say that Cerrado, proportionally speaking, yes. So in the recent years, if you think like the Cerrado is having a deforestation that would be equivalent to last year, for example, was like 60% of the level of deforestation that we have in the Amazon. But the Amazon is kind of 3 times the size of Cerrado. So yeah, so proportionally, Cerrado has more deforestation. But there was certain years, like between 2012, 2011 and 2015, 16, the level of deforestation, the absolute number of deforestation in Cerrados was higher than the Amazon. So in absolute terms. Now the deforestation is growing in all biomes. Like we just launched a report last week showing that, making analysis of the deforestation events in Brazil last year. So we had 74,000 events of deforestation in Brazil with 1.3 million hectares, and it grows in all the biomes. But in the Amazon, when you grow 10% in the Amazon, it's like a big area, right? So 60% of the deforestation last year was in the Amazon, and another 30% was in the Cerrados. So 92% of deforestation will happen in just those 2 biomes. Yeah, and mostly what happens in Cerrado is just direct conversion to pasture and agriculture. And pasture most of the time now is actually just a transition for agriculture later on. So it's a big debate, because you say like, oh, you clear cut the forest, and what happens next year? Well, next year probably you have pasture, or you have like just an area in transition. But 3-4 years down in the road, and you see the cropland, especially soybean growing there.
Mm-hmm. Okay, I've got another question. So with all the data that you use in the MapBiomas project and the platform that you showed, how could additional data, such as we're hoping to collect with the Earth Archive, be integrated into it? And what type of analysis do you see that could be done? Could it further your analysis, basically?
Yeah, so, well, let's say like, it's interesting to see how people are using the data, right? So there is, we just have what we call the MapBiomas Award. So we kind of select different applications of the use of this data. And there was like, we find out 153 applications this year, like different applications. So there's many areas that of interest. The 2 that we are working now strongly, one is to combine the information on carbon, not just the carbon emission, but the carbon content, not just in the forest or in the surface, but also in the soil. So the next thing that we are putting together is a kind of historical mapping of the carbon content in the soil. So then we can estimate what is the variation of carbon that's happening in the soil, which will be very important. So this is just to give you one example of something that is extremely important, because like if you take pasture land in Brazil, like the main source of emission agriculture, in our case, is animals, right? It's the cattle. But if you have a poor pasture land, you have the emissions from the pasture and then the animals plus the emission from the soil. But if you manage correctly, and then you are concentrating carbon in the soil, you can even compensate the emissions of the cattle. So this could be turned into something that is like a huge bump of emissions today to something that could be actually negative emissions just by managing better the soil. And so we are, focusing. This is one of the topics. The second topic is biodiversity in general. So there is this big archive of that is also made by a network of 160 institutions that are working, that put together this something called CRIA, where you have all the information about biodiversity in Brazil. And so we are geolocating all this information and make a connection between the two platforms. So you could analyze the change on the landscape, on the land use, and etc., and see what is the impacts and vice versa on biodiversity. And there is this new idea that we have been discussing recently of understanding for example, the archaeology on the Amazon and bringing information about the archaeology inside the same platform. So these are different ways of doing. As is a network, so it's always open to anything that we can connect that and can help people to take better decisions.
That's really interesting. So if we can get really, very high fidelity LiDAR data for more of the Amazon, you can even increase the accuracy of those carbon sequestration estimates, I assume.
Yeah, so you bring another point. So we are discussing also with the Forest Service in Brazil to bring all the information from the National Forest Inventory. It's amazing, but the first National Forest Inventory in Brazil is just being completed right now. We never did this before. So it was a 10 years effort. So you have all those plots in Brazil. And so now we can use this information to locate them and make it available so people can understand the landscape and also understand the content that you have on each one of the plots, about 20,000 plots that were made in the country. But yeah, so the information that we can have in LiDAR will be like absolutely crucial. So there is this initiative. We just put out a proposal for funding to do the first 100,000 square kilometers of LiDAR imagery in large scale, 10 centimeter resolution, etc. It's just like a lot of data, right? And it takes a lot of time, but we are confident that this will bring not just information on the carbon. I think this will bring us information about structure of vegetation that are unprecedented to understand the region. And I think once you have that, also we'll be able to map even species, because you can identify species on this way. So I mean, there is a whole new world that you can see once you have this 3D information about the Amazon.
Exactly. I can't agree with you more. It's a whole new world of things you can see.